So let's talk about even and odd functions. So even and odd functions, just to go back and review, we're going to go to Algebra World for a couple seconds. So an even function means that it's symmetric across the y-axis. So let's look at our friend, the parabola. Okay, so we're doing even. All right, so an even function is symmetric across the y-axis, which means if I fold a piece of paper like this, okay, and if this is the y-axis, then its little arms, so I've got my parabola coming up here, and I've got my that was lovely, and my parabola coming up there, okay? So what happens is when I fold it on the y-axis, you're going to see that this arm lays on top of that arm. Well, that's kind of hard to do when there's an infinite number of points. So we've got a couple of ways to formalize this. The first way is, first of all, just because something starts off as a parent function, if the parent function is even, that doesn't mean it's always even. Because as soon as I shift that thing to the left or to the right, it loses its evenness because I can no longer fold it on the y-axis. But I can move it up, down, and I can flip it. I can reflect it across the x-axis. I can stretch it. I can compress it. I just cannot move it left or right, or it loses its evenness. So what does that mean? What that means is this. F of x is going to equal f of negative x. Okay? F of x is going to equal f of negative x. So let's put that in the context of our parabola. If I just grab an x value, let's say 4. Okay, so the point 4, 16 is on that function. Why? Because 4 squared is 16. Okay, so now what do I know? Well, let's put in a negative 4 just for kicks. If I put in a negative 4, guess what point is also on the graph of my function? So negative 4 times negative 4 is positive 16. So what you find out is that the y value produced by x, okay, will be the same y value produced by negative x. If you change the sign, it's going to give you the same y value. So what do you know from that? Looking at your list, hang on, I've lost my list. Where's my list? Where are my identities? On page 2 of your identities. Found them. On page 2 of the identities that I gave you, you'll see evens and odds. Okay? So what's even? Cosine is an even function. Okay, so if you change the angle measure on cosine to just the opposite, if it was negative, you make it positive, or if it was positive, you make it negative, it's going to give you the exact same ratio. So let's think about that for just a second. If I grab my unit circle, okay, and let's just say, what's the cosine of positive 45? Well, the cosine of positive 45 is root 2 over 2. Okay, so let's go to the cosine of negative 45. So I'm going to drop down 45 degrees. And the cosine of negative 45 is also root 2 over 2. Okay, so your even functions are cosine and secant. Your even functions are cosine and it's reciprocal. So what's an odd function? So an odd function means that it's going to be symmetric about the origin. Symmetric about the origin. So, what does that mean? So let's go back to Algebra World and let's tell you that we've got y equals x cubed. Okay, so this time we're going to do 2 folds. I've got x cubed coming up this way and going down that way, which you cannot see. Okay, so I've got x cubed going up this way and down this way. So what does that look like? So let's grab a point. Let's grab 2. So if I grab an x coordinate of 2, 2 cubed is 8. Okay, so if I grab a 2, 2 cubed is 8. Well, now let's change its sign and see what happens. So I'm going to go negative 2. What happens when I shove in a negative 2? Negative 2 times negative 2 times negative 2 is negative 8. So the point, not drawn to scale, negative 2, negative 8 is on your cubic function. So what that means is it's symmetric about the origin. If I fold this over to here, then what you're going to discover is that this arm is going to lay kind of like right there, okay? And then you fold it again across the x-axis. And now this arm, which did go to quadrant 2, now drops down into quadrant 3, and it lays on top of that arm over there. So we say that it is symmetric about the origin. And the way that I look at that is I can say that f of negative x becomes negative f of x. Okay? If I change the signs on one, it's going to change the sign on the other. So if this was a positive 2 and it gives me a positive 8, change the sign. So this 2 will become a negative 2, and then change the sign again. That'll become a negative 8. So now I can flip that thing, okay? So to keep this odd, I cannot move it. Do not move left, right. Do not move up, down. But I can reflect, and I can shift. Or no, I can't. I can reflect, and I can stretch or compress. I cannot move, okay? So let's think about that for just a second. If I flip this thing, so let's go to, I've got negative x cubed. My stupid pencil just ran out of lead. Okay, give me a second. Here we go. All right, so I've got this, which is now negative x cubed, so it looks like this, okay? It's still odd. So if I shove in a positive 2, I'll get a negative 8. Well, because it's odd, I can change those two signs, and I'll know another point on the function, which means negative 2, positive 8 is also on the function. So you just change both signs. That's what that means. Okay, so if you'll notice, I changed this sign, and it was a positive answer. I changed this sign, and it was a negative answer. And so it means change both signs. So what is an odd function? An odd function is going to be sine and his reciprocal, which is cosecant. Sine and his reciprocal, which is cosecant, and then tangent and his reciprocal, which is cotangent. So the only even ones are cosine and his reciprocal. So the next thing that we want to do is look at the periods of these functions. So we did evens and odds. Now we're going to do the periods of these functions. So what is the period of a function? It means how long do I have to generate this thing before it starts repeating itself. Okay, so the period of a function is the width. It's how wide the interval is before it starts repeating itself. And that we referred to, but I didn't really cover. Okay, we referred to, and it's at the bottom of page 1. So you'll notice that for sine, cosecant, cosine, and secant, your periods are multiples of 2 pi. So if I start at 30, okay, and if my integer multiple is 1, then 30 plus 1 times 2 pi. So 30 plus 2 pi is going to give you, guess what? It's going to give you 390, okay? So it gives you, it results in a coterminal angle is what it does. So the period of sine and cosecant is going to be 2 pi or multiples. The period of cosine is going to be 2 pi or multiples. But once again, tangent and cotangent have to break the pattern. Their multiples are 1 pi's. Okay, 1 pi. So as soon as you go around the unit circle halfway, it's going to start repeating itself. Whereas with these 4, you've got to make a full lap around before it starts repeating itself. So what are we looking at when we start, because this section 7.5, is essentially taking everything that we've learned and applying it to the unit circle. Well, I've already taught you the unit circle, so this kind of gives your brain a break, okay? So we're just going to look at different ways to apply what we've learned. So if I've got the sine of theta equals 0.2, and that's a ratio, okay, that's 2/10 or 1 to 5. So that is a ratio. We just wrote it as a decimal. Okay, I would like to know what is the sine then of negative theta, and then what is the sine of theta plus 2 pi. So the sine of theta plus 2 pi. So I don't even have to know what the angle measure is. I can just apply what I know. So using even and odd properties, I know that sine is an odd function. So if a positive angle measure gave me a positive ratio, then a negative angle measure will give me a negative ratio. So for an odd function, if you change the sign, you got to change it on both places. Okay? If this was cosine theta is 0.2. Well, then what's the cosine of negative theta? Well, this one just says whatever your input is, it doesn't matter because cosine is an even function, so I can effectively ignore that negative. Okay, so guess what? It's still going to be 0.2. Okay, so that's the power of even and odd functions. Well, this is the periodicity of the function. So I take sine of this angle, but I add a lap to it. So I have now found a coterminal angle, which means I just landed at the same spot. So I don't care. Again, I do not care what the angle measure is. I do know that the ratio is 1 to 5 or 2 to 10. Okay, so I get here, well, I'm going to add a lap. So rip around one lap and you're going to land at the exact same spot. So that has an answer of the same ratio that the original angle had. Okay, so let's try another one. Let's say I've got, I want the cosine of 13 pi over 6. Okay, so the cosine of 13 pi over 6. And I want to look at the periodicity of the function. Okay, so first of all, I know that I am not in the first lap of the unit circle. How do I know that? Because if I double my denominator, I'm in radians. If I double my denominator, then one full lap is going to be 12 pi's over 6, because that reduces to 2 pi. Okay, that didn't help at all. Okay. So what happens is I'm an additional pi over 6 into the next lap. Okay, so I'm going to use the periodicity of the function, which means my values will repeat every 2 pi. So I now know that I am 12 pi's over 6 around, and I'm going to go an additional pi over 6 to get to 13 pi's over 6, which means by the period of the function and by the fact that these two angles are coterminal, I find out that this is going to give me the same ratio as cosine of 1 pi over 6. So again, what did I do? A full lap is 12 pi's over 6. I went an additional pi over 6 to get to 13 pi's over 6. Okay, so these two things are coterminal, which means this is just pi over 6 plus a lap. That's what that is. Do I know that ratio? Yes, I do, because it is a benchmark angle, and that ratio is √3 over 2. So now I know how to do that one. What about the sine of negative 30 degrees? Okay, the sine of negative 30 degrees. Well, I can use even and odd properties. I can use the reference angle. Okay, I can do all sorts of stuff. Recognizing that the sine of negative 30, okay, I can figure out that the sine of positive 30 is positive 1/2. Because sine is odd, the sine of negative 30 will be negative 1/2. So if I change this sign, I better change that sign. So look at your unit circle. If I drop down 30 degrees, I find out that sine is negative 1/2. Okay. So what if I have something like, let's do the tangent of negative pi. We're just going to make one video in this section. It's just going to be a little bit longer. So I've got the tangent of negative pi, and I'm going to add that to the sine of negative pi over 2. Okay, so we're putting a bunch of stuff together here. So I know that this is a negative angle. Okay, so I can use the property of even and odd functions to figure out what this is. So I also know that pi and pi over 2 are quadrantal angles. So my answer is either going to be 1, -1, 0, or undefined. Okay, so first of all, tangent is an odd function. So let's find the tangent of positive pi, and then we'll change its sign. Okay, so the tangent of positive pi is the ratio of y, which is 0, to x, which is -1. So that is the ratio of y to x, which means that is 0. Well, guess you can't change the sign on 0, so guess what this is? It's 0. Okay, but look as well, I could have just gone backwards. So from standard position, I'm going to drop down and circle around to pi, and I find out that I landed in the exact same spot, so they're coterminal. So I end up with y to x, so 0 divided by -1 is still 0. So this is also a quadrantal angle. Okay, so I've got the sign of -pi/2. Well, that is going to be an odd function. So what I can do is find out the sign of pi/2, which is going to be 1. So he's 1, but I actually want the sign of -pi/2. So since I changed the signs here, I need to change the signs here. So the sign of -pi/2 is -1. So I have 0 plus -1 is -1. Now what happens if I drop down to pi/2? My y value is -1. Okay, so let's do one more. And we'll go to the sine, maybe two more, maybe a few more. The sine of -49pi/6. And then I've got minus the tangent of -49pi/6. So it's the same thing. I'm sorry, it's not the same thing. It's the same angle measure. All right, so first of all, I want to figure out where I'm at. Okay, so here's what I can do. I can find an equivalent expression by if I change this sign, meaning positive, negative, I can change the result. So right now, this is a positive result because it says +1 sine of whatever. Or I can just turn around and find out a coterminal angle. So just because you're learning about even odd doesn't mean that reference angles and coterminal angles stopped existing. It just depends on how you want to figure it out first. So I tend to drift towards coterminal angles. So what I want to do is find a multiple of 6. I want to know what one complete lap is. So one complete lap means I double my denominator. So a complete lap is 12pi/6. And then what I can do is start adding 12 to -49 because I've already got the pi's, I've already got the 6's. I can add 12 to -49 until I get a number between 0 and 12. Because 0 would be standard position and then 12 would be a full lap. So I can say -49. So -49 plus, oops, sorry, I just did all that messed up, plus 12, okay, plus 12, plus 12, plus 12, plus 12, and I get 11. Okay, so 11 pi/6. So this thing is the same thing as the sine of 11 pi/6 minus the tangent of 11 pi/6. Well, now if you want to use reference angles, you can, because how far away are you from standard position? You are pi/6 away. So if I find the sine of pi/6, then I can recognize I'm in quadrant 4, so this is going to be negative. Or I can just say, hey, the sine of 11 pi/6 is in quadrant 4, and it's negative. So the sine of 11 pi/6 is going to be -1/2. Now, let me tell you what's happening here. What I could have done was I could have said negative sine of positive 49 pi/6. So when I got to positive 49 pi/6, that's going to give me 48 pi/6 is a complete lap. So I'm at positive pi/6. The sine of pi/6 is 1/2, but I changed its sign. So I got the same answer 3 different ways. Okay, I used even and odd properties here. So I changed the sign here, which means I changed the sign on the outside. Some people will say, oh, you factored it out. You can kind of sort of look at it that way, but that is absolutely not at all what you're doing. Okay, and that's only for even and odd functions. You are not factoring that out. All you're doing is applying even and odd functions. It kind of looks like you did, but you didn't. Okay. Another way to do it is I just identified the sign of 11 pi over 6 as negative 1/2. And the third way I did it is I said, okay, I know that my reference angle is pi over 6 because I am pi over 6 away from a full lap. So the sine of pi over 6 is 1/2, but 11 pi over 6 is in quadrant 4. So sine is negative in quadrant 4. So 3 different ways to come up with the same answer. So now what can I do? Well, the tangent of 11 pi over 6 is going to be the ratio of y to x, which at this point you should be able to do. And that's going to give me negative root 3 over 3. Okay? So the ratio tangent at 11 pi over 6 is negative root 3 over 3. Okay, so now I need to get a common denominator. So I've got this thing is going to turn into addition. Okay, so I carried this subtraction, and then I got a negative ratio here. Well, my common denominator is going to be 6. So I'm going to multiply those by 2's. So I get negative 3 plus 2 root 3, and all of those are over 6. Okay, so all of my numerators are over 6. All right, what is something else I can do? You can find range. You can tell me what is done. All right. So that is brilliant. Okay, so you should have a good foundation for 7.5. So we're just going to do one video on this one. And we got 3 sections left, and you're ready for your test.